So today's lesson 2.6, ratios and proportions. So two objectives. The first is to compare ratios, and with that, basically seeing if one ratio is equivalent to another ratio. And then once we know that, we can use that to solve proportions. So let's take a look at the key vocabulary, the new vocabulary. So ratio and proportion are going to be the two keywords that start everything off. Everything underneath that is what we're going to be looking at for today. So first thing is that key term ratio. So a ratio is a comparison of two numbers by division. And we can express that three ways. So the first one in words, x to y. Second one with the colon, x to y. It's the way we say it. And the last one, the important one, it's still x compared to y. However, that's the one that we're going to be focusing on because we can do math with the last one. So if one ratio is equal to another ratio, then we have a proportion, which is what we have here for the word problem that's given there. So notice in the numerator we have restaurants and the denominator is people for both of those ratios. I like to call that the key ratio. So my key ratio is going to be restaurants in the numerator, the number dealing with restaurants, and people in the denominator. That's my key ratio. And if I take a number like the 0.313 and multiply it by 10, well, I'm just moving the decimal place over. And so I'm moving it over one place, so that 0.313 becomes 3.13. 10,000, I move the decimal over one place, so this one moves over here, and that becomes 3.13 over here. Here's the decimal point here. If I move it here, that means I'm adding the zeros, so that becomes 10,000. Well, those two ratios are equivalent to each other. That's a proportion. We're going to be looking at that today. So first we have to determine if ratios are equivalent. So the question in example 1 says, determine if 2/3 and 16/24 are equivalent ratios. So here's one way of looking at that. It says, when expressed in simplest form, the ratios are equivalent. Well, 2/3 is already in simplest form because 2 is a prime number and 3 is a prime number. They have no common factors other than 1, which is why dividing by 1 gets you the same thing. On the 16/24, their greatest common factor is 8. So divide both of those by 8, and you actually can simplify it back down to 2/3. I do want to show one other way, and that's using the calculator. So if we use the calculator and we get the same decimal answer, so 2/3, which is 0.6 repeating, and 16/24, which is also 0.6 repeating, then we'll be able to verify it. So let's look at that. So 2 divided by 3, there's my 0.6 repeating. Clear everything else out. So 2 divided by 3, there's my 0.6 repeating. My other fraction is 16/24, so 16 gets written first, divide 24. If I want the decimal, well, those two are decimal equivalents. They're both 0.6 repeating forever and ever. Another way to do that is to actually write 16/24 as a product of its prime factors. So in other words, the prime factorization of 16 is 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Prime factorization of 24, so 2 times 2 is 4, times 2 is 8, times 2 is, actually, excuse me, that's 2 times 2, 2 times 2 is 4, 4 times 2 is, yeah, excuse me, times 3. That's my factorization. That's so here, 2 times the check out 2 times 2 is 4, 4 times 2 is 8, 8 times 3 gives you 24. So I am going to rewrite 16/24. Let me put that on a new page. So 16/24 is equal to 2 times 2 times 2 times 2. There's the 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. And then 24, its prime factorization, 2 times 2 is 4, times 2 is 8, times 3 gives you your 24. we simplify. 2 divided by 2 simplifies to 1 over 1. 2 divided by 2, 1 over 1. 2 divided by 2, 1 over 1. And what's left in the numerator, 1 times 1 times 1 times 2 is 2. In the denominator, 1 times 1 times 1 times 3 is 3. There's another way to visually show that, but you could easily divide by 8. That's fine there. And you'll get that answer. All right, so go ahead and take a look at guided practice 1A and 1B. Go ahead and pause the video. So determine whether each of these ratios are equivalent, yes or no. All right, so we're looking at, there's our guided practice 1A. So 1A says 6/10 and 2/5. Well, 2/5 is already simplified because 2 and 5 are prime factors or are already prime numbers. 6, and I'm just going to rewrite this a little bit differently than the book. 6 and 10, if I look at the greatest common factor, that would be 2 between them. So 6 divided by 2 in the numerator, that gives me 3. 10 divided by 2, that gives me 5. And 3 and 5 are prime factors, so that's the simplest form. 3/5 does not equal 2/5, so 6/10 and 2/5 are not equivalent. Um, they're not equivalent ratios, so it would be no. It says determine whether they're equivalent. So this would be no, because let's go ahead and justify that. 6/10 simplifies to 3/5, and that is not equal to 2/5. So that would be the answer for that one there. And if we did use the calculator, let's go ahead and so 6 divided by 10. There's my 0.6 as a decimal. By the way, I can hit math, enter, enter. There's my 3/5, and then 2/5. 2 divided by 5 gives me 0.4. If I hit math, enter, enter, well, that'll give me 2/5. So they're obviously not the same decimal answer. They do not simplify. Lots of reasons as far as why not. So for 1B, 1/6 and 5/30. Well, 1 is not a prime number. The definition of a prime number has to be 2 or greater to be a prime number. But it is already simplified. It has 1 and 6 have no common factors other than 1. So that's already. The 5/30 can be simplified. So let's do that. And for this one, and actually for 1A, I do want to go back to the 6 and 10 as prime factorization. So 6, the prime factorization would just be 2 times 3. For 10, the prime factorization would be 2 times 5. And then if I rewrite that, 6 over 10 equals 2 times 3 over 2 times 5. 2 divided by 2 simplifies, 1 over 1. And there's our 3/5, same way as the other one. Now let's go back to 1B. So 5 over 30. If we divide both by 5, well, that's going to give us 1 over 6. That is equivalent to 1 over 6. And 5 is already prime, so don't have to write that. But 30, prime factorization. And another way to do prime factorization, if you're not sure, is to do a factor tree. So, for example, you can do this lots of different ways. Let's do this one. So 2 times 15. So 2 is prime, so you circle it. 15 is composite because it has factors other than 1 in itself. So this would be 3 times 5. 3 is prime, 5 is prime, so it's 2 times 3 times 5. Even if I did 3 times 10, well, 3 is prime. 10 would be 2 times 5. And I still get the same factorization because 2 times 3 times 5 is the same thing as 3 times 3 times 5. We usually normally write it in order from least to greatest. So 2 times 3 times 5. And so if I did 5/30, that's going to be equal to 5 divided by 2 times 3 times 5. 5 divided by 5 simplifies to 1 over 1. That means you're left with 1/6. So this is yes. And the reason would be because 5/30 simplifies to 1/6. That would be the reason. All right. let's move on. So there is a special name for terms in a proportion. So I really don't want to use this example here because it has the decimals. Um, but if we were to do this as a nicer number, for example, so we'll look at it. So let's say if I wanted um, 3 to 4, and I want to compare it to 6 to 8. Well, that would be 3 to 4 and 6 to 8 as a fraction, 3/4 and 6/8, which is still 3 to 4 and 6 to 8. And these are the same number because if we did get the calculator, 3 divided by 4 is 0.75, 6 divided by 8 is 0.75. That would be the other way, by the way, to do this in the calculator on this one. 1 divided by 6, there's my 0.16 repeating forever, 5/30ths. There's my 0.16 repeating forever. This is a way to verify it, not really a way to explain it mathematically, which is what's on the board now. Okay, going back to over here. So means and extremes. So I'm actually going to um, repeat this with the numbers that I wrote. So it would be 3 to 4 is equal to the ratio of 6 to 8. So the 3 and the 8, just like the 0.2 and the 9.0, are the extremes. They are at the extreme ends of this equation, of this equality. And then the inside, the 4 and the 6, would be the means, and they're on the inside of this proportion, this one ratio equal to another. So if we were to look at this in terms of a fraction, so 3/4 equals 6/8, the top left and the bottom right would be the extremes. The bottom left and the top right, 6, would be the means. Well, here is the property that we use. If one ratio is equal to another ratio, then we call that equality a proportion. When you have a proportion, the product of the means is equal to the product of the extremes. Nobody really calls it the means extremes property of proportion. Most people call this cross products, cross multiply, and I do want to show that as far as with 3/4 and 6/8. So 3/4 equals 6/8. So if I look at 3 times 8, 3 times 8, is that equal to 4 times 6? Yes, it is, because 3 times 8 is 24, 4 times 6 is 24. When the cross products of a ratio are equal, um, then you have a proportion. So that's how we know. And then just like with the example they have here, 2/4 equal to 1/2. Well, 2 times 2 is 4, 4 times 1 is 4 as well. All right, so let's take a look at using the cross products rule with the means extreme property of proportion. So we want to see, like on A is 2 divided by, or is the ratio of 2 to 3.5 equal to the ratio of 8 divided by 14? Well, and you see that here. So 2 times 14, that gives you 28. 8 times 3.5, that gives you 28. So this is in fact, this uh, these ratios are equivalent to each other, so they do form a proportion. That would be the answer. If we take a look at B, we have the ratio of 0.3 to 1.5, 0.3 divided by 1.5, and then 0.5 divided by 2.0. If we look at the cross products, and so one way you could do that is 0.3 times 2.0, that's 0.6. 1.5 times 0.5, well, that's 0.75. So they are not equal, so the cross products are not equal, the ratios do not form a proportion. So at this time, take a look at guided practice 2A and 2B, and go ahead and pause the video so you can try these two problems for yourself. So for 2a, we've got, we're looking at, let's test this. So 0.2 divided by 1.8. We want to see, is it equal to 1 divided by 0.9? And to test this, we look at the cross product. So 0.2 times 0.9. Those would be our extremes. And we want to see, is that equal to 1.8 times 1? And so with decimals, you always want to be careful, especially these numbers here. So zero point 0.2 times 0.9. Let's take a look at a calculator. 0.2 times 0.9. Well, that's going to give me 0.18. So 0.18. And then 1.8 times 1, well, that's just 1.8. Since 0.18, this statement is false. Because it's false, the ratios do not form a proportion. The ratios do not form a proportion. All right, so now let's take a look at 2b. So 15 divided, the ratio of 15 to 36, so 15 divided by 36, does that equal 35 divided by 42? So to set this up, we're going to look at the cross product of the extreme, so 15 times 42, and we want to see, does that equal the product of the means, 36 times 35? So let's use our calculator. 15 times 42, so 15 times 42, that product is 630. And then we have 36 times 35, so 36 times 35, that equals 1,260. So those ratios do not form a proportion. Let's see, look there. So I believe this one was 630. What was that? 630, yes, and then 1260 equals 1260. So that math statement is false. It does not equal that. So these ratios do not equal, or these ratios do not a form a proportion. So I do want to show, as far as one, that if we wanted to test, for example, 3/4 equal to 6/8, we looked at this one before. They are equal to each other because 3 times 8, if we look at the product of the extremes, 3 times 8, and set it equal to the product of the means, 4 times 6, well, 24 equals 24. That is a true statement, which means these ratios do form a proportion. All right, so let's take a look at the kinds of problems that you could do from examples 1 and 2 that we did. They will help you answer problems 1 through 3 and 9 through 14. Remember, in the back of the textbook, you do have the answers to the odd numbered problems. And if it's an odd number problem in green, like number 3, it will actually show you the solution, the steps to get the answer, not just the answer itself. All right, so let's take a look at solving proportions. Once we know, or once you are told a ratio is equal to another ratio, then you can use that proportion to solve for a variable like we have here. So here we've got x, the ratio of x to 10, so x divided by 10, equal to the ratio of 3 to 5, 3 divided by 5. So we are going to take the product of the extremes, x and 5, that's what you see here, x times 5 in parentheses, and then set it equal to the product of the means, 10 times 3. Well, 5x equals 30. Divide both sides by 5, x equals 6, and check it in the original problem. 6 divided by 10, does it equal 3 divided by 5? Well, 6 times 5 is 30, 10 times 3 is 30, so x equals 6 is correct. If we look at B, this one's a little bit more interesting because it's the ratio of the difference of x and 2 divided by 4, or 2 14, so x minus 2 that divided by 14 equals 2 over 7. So we're still doing the means extremes property of proportion. So x minus 2, that gets multiplied to 7. And you see that quantity x minus 2 times 7, so we're using distributive property. 7 times x, 7x, 7 times a minus 2, minus 14, and setting it equal to 14 times 2. Well, this is a two-step process to solve for x. They don't show that you're adding 14 to both sides. If you did that, 7x minus 14 equals 28. Well, add 14 to both sides, and 7x minus 14 plus 14 is 7x, and that does give you 42. Notice they don't show the division of 7 on both sides. If I were to show that, that would be another step. Over here, 7x divided by 7 equals 42 divided by 7. 7 divided by 7 simplifies to 1 over 1. 42 divided by 7 simplifies to 6. So x equals 6 is the correct answer. And if we substitute this back into the original, 6 minus 2 divided by 14, that's just going to be 4 over 14. And let's go ahead and set that equal to 2 over 7. The 6 minus 2, that's the same thing as 4 over 14, equals 2 over 7. And guess what? 7 times 4, 28. 14 times 2, 28. That's how you would solve for the variable x. All right, so at this time, go ahead and look at guided practice 3A and 3B. Go ahead and pause the video so you can try these problems on your own. So for 3A, we've got the ratio of r to 8, so r divided by 8. Let's write that over here. R divided by 8 equals the ratio of 25 to 40, so 25 divided by 40. And we're going to look at the means, extremes, property of proportion, cross products. So r times 40, set that equal to 8 times 25. And r times 40, well, that's just 40r. 8 times 25. If you need the help of a calculator, please use that. 8 times 25, well, it's just 200. And now we're solving for r. So we have 40 times r to solve for r. 40 times r is going to be divided by 40. Golden rule of algebra. Whatever you do on one side, you do to the other. So 40 divided by 40 simplifies to 1 over 1. R is equal to the quotient of 240. So 200 divided by 40 is what you would put. 200 is the numerator. Type that first. Divided by your denominator. Type that after the divide sign. So 5. 5 is the answer for R. And if we go back to the original, 5 divided by 8, substitute 25 times 40. Well, we know 5 times 40, we just did that, that's 200, and 8 times 25 is 200, so that is correct. All right, let's take a look at guided practice 3B. So here we've got x plus 4 in the numerator. That's being compared to 5. So your ratio of the sum of x plus 4 and 5 is equal to the ratio of 3 to 8. And we're going to use, if one ratio is equal to another, we can set the cross products equal to each other. So this, I'm going to set this up a little different. I'm going to put 8 times the quantity x plus 4 and set that equal to 5 times 3. Distributive property, 8 times x and 8 times 4. So we've got 8x plus 32 is equal to 15. Solving for x is going to take 2 steps. The first step is going to be to subtract 32 from both sides. So minus 32 minus 32. On the left-hand side, we've got 8x plus 32 minus 32. That simplifies to 8x. And then on the right-hand side, we've got 15 minus 32. That gives us negative 17. And we'll check that. 15 minus 32. There's our negative 17. And we're solving for x. So x is being multiplied by 8. So 8 times x divided by 8 equals negative 17 divided by 8. 8 divided by 8 leaves us 1 over 1 times x is just x. And our number for x is negative 17/8. That is the value of x. And if we substitute that here, we should be able to add that add 4 to the number, divide it by 5, and get 3/8. So I do want to show you that in using the calculator. So here I do need a fraction, and then I need another fraction. In the numerator, I need, first of all, it's going to be negative, and then another fraction. So if you have a CE calculator, it's alpha button X. If you have a regular 84, it's alpha button Y equals button 1. And I believe that's 17 over, let's double check, 17 over 8, negative 17 eighths for X. And then that number plus 4, that follows everything from over here. And then I'll divide that by 5. When we hit enter and scroll to the right, that should give us our 3/8, and it does exactly there. So please use the technology to help verify your math answer. Once it's verified, now we know that is the correct solution. And that will help you answer problems 3 and 4, uh, or excuse me, problems 4 through 6, or like example 3, and 15 through, let's take a look, 29. And remember, odd answers are in the back of the book. Um, the odd numbers that are in the green circle are the solutions are there, not just the answers. So that's even more helpful. All right, so that leads us to our next two vocabulary words, rate and unit rate. Well, if a ratio has two different measurements, then that ratio is called a rate, and we use rates all of the time. So, for example, the price of gas is the number of dollars for every 1 gallon. So it would be dollars in the whatever that happens to be, 250, whatever. So 250 for every 1 gallon. While our ratio would be dollars in the numerator and gallons in the denominator. It's the ratio of dollars to gallons. In this problem, we have this information. It says, in the past 2 years, the retailer opened 232 stores. That's a ratio. It's 232 stores for the 2 years. So the key ratio is going to be retail stores compared to the number of years. So this is what I like to call the key ratio. I keep that key ratio the same. So we want to know if, based on this ratio, how many would be open in a 3-year time period. How many would be open? So we've got this ratio, 232 over 2 is equal to R over 3. Well, cross products, cross multiply, 232 times 3, there's your 696. 2 times R, divide both sides by 2, and in 3 years, you would expect 348 stores to open. So even though 348 equals R, the answer to the question would be the retailer would open 348 stores in 3 years. Now, uh, the the other thing you could do is actually find, well, if it was 232 in 2 years, what would that be in 1 year? Well, if we do that, that's actually going to find the unit rate, how much it is for every 1 unit in the denominator. So if it's 232 for 2 years, well, 232 divided by 2 is the same ratio as 116 divided by 1. And if we keep that the same, it would be 100, or the ratio the same, 116 retail stores for every 1 year. Multiply that by 3, and let's use our calculator. 116 times 3, there's your same answer, 348. Lots of different paths that you can take to get to the answer. All right, so at this time, let's look at guided practice number 7. 7 minutes for Isabella to walk around the gym track twice. At this rate, how many times should she walk around the track in a half hour? So go ahead and pause the video so you can try guided practice 4 on your own. All right, so for this example, we're looking at our key ratio would actually be the minutes in the numerator divided by the number of laps around the track, so laps in the denominator. So that's our key ratio. And the information that we're given, it takes 7 minutes. So 7 minutes for 2 laps around the track. And we want to know, based off of this ratio, how long would it take to do um, half an hour? Well, 60 minutes is an hour, so it would be 30 minutes. Or how many laps, how many times around the track? So that would be our X number of laps. So because our key ratios are the same, minutes to laps, minutes to laps, let's make it look like minutes in here. Minutes, we can actually just look at the values. 7, the ratio of 7 to 2 equal to the ratio of 30 to x. So 7 divided by 2 equals 30 divided by x. We can set our cross products equal to each other. So 7 times x equals 2 times 30. 7 times x is just 7x. 2 times 30 is 60. And to solve for x, which is the number of laps for 30 minutes, 7x divided by 7 equals 60 divided by 7. 7 divided by 7 simplifies to x over 1. And with the help of our calculator, 60 divided by 7 is going to give us approximately 8.6 if we were rounding, so not equal to, but approximately equal to 8.6. So we can answer the question now. It would take about, about 8.6 left, or she would walk. That's actually, rephrase that correctly. She would actually walk. So she would, I think she's walking. Yep, she would walk. That's about 8.6 laps in 30 minutes. That would be the answer to the question. All right, so now let's look at 7 and 30 at the end of the lesson. They're very similar to example 4 that we just did. Set up a find your key ratio and set up a proportion. So that leads us to the last example, scale and scale model. So we set up scales to represent numbers that are too large or too small. So in this information, it says the Ramsey Cascades Trail is about 1 1/8 inch long on a map with a scale 3 inches equals 10 miles. Well, that's a ratio. It's 3 inches for every 10 miles, which means we can set this up as 3 inches for every 10 miles. That is so our key ratio is inches to miles. Everything needs to be set up with inches to miles to be able to set this up. And we are looking at, that's pretty much what's set up here. So we have 3 to 10 is equal to, there's our 3 inches for the 10 miles, is equal to the actual scale, 1 1/8 inches over the length itself. So we're using cross products. 3 times L gives you your 3 times L there, and 10 times 1 1/8. Now, the 1 1/8 times 10, that's a little interesting. It just gives you the answer. It doesn't really show you how you get that answer. This is going to involve going from a mixed number to an improper fraction. So 1 1/8, the 8 gets multiplied by 1, and that product gets added to 1. So this would be equal to 8 times 1, that's 8, plus the 1 gives you 9. Uh, and then keep the denominator the same. That's going to give you 9/8. And now that is being multiplied to 10. So 9/8 times 10, well, that's the same thing as 9/8 times 10 over 1. So 90 divided by 8, and that simplifies. So if we look, let's put it over here. 90 divided by 8. If I wanted to, I could do prime factorization. I could also just find the greatest greatest common factor, excuse me, to find it. And so that's actually um, going to be 2. So if I did, that's equal to 90 divided by 2 equals 8 divided by 2. There's my 45 divided by 4. And there are no common factors between 45 and 4, which is why we get 45 fourths there. And here, uh, where we're solving for L, so we need to divide by 3. And again, it's showing 45 divided by 3 without showing how we get to that answer. So 45 fourths is being divided by 3. Well, in math, when you're dividing, and this is the same thing as dividing by 3 over 1, if you're dividing a fraction, that is equivalent mathematically to multiplying by the reciprocal. When you multiply fractions, you multiply straight across. 45 times 1, 45. And then we're 4 times 3, that product gives you 12. Uh, the greatest common factor between 45 and 12 is actually going to be 3. So 45 divided by, this is equal to 45 divided by 3 equals 12 divided by 3. If I'm dividing by the greatest common factor, greatest common factor. So this gives me 15 in the numerator and 4 in the denominator, which is what we get right here, 15 fourths for the length. And because we were given mixed numbers in the original problem, it's usually a good idea to write your answer in as a mixed number as well. So 15 fourths, if we look at 15 fourths, we can rewrite this as the sum of 2 fractions. So let's look at our multiples of 4. So 4, 8, 12. So this is equal to 12 fourths plus 3 fourths. Well, 12 fourths is 3, so that's just equal to 3 plus 3 fourths, which means we can write it as our mixed number 3 and 3 fourths. Lots of ways to do this. You need to find a method and process that works for you. All right, so at this time, let's go ahead and take a look at the guided practice. Pause the video so you can try this problem on your own. So the very first thing it tells us is we have a scale of a ratio of 5 centimeters for every 2 meters. So 5 centimeters, and that's abbreviated. 5 centimeters for every 2 meters. Well, we're going to keep that ratio the same because our key ratio is centimeters in the numerator, meters in the denominator. We want to know if the model's wingspan is 28.5 centimeters. So keep the centimeters in the numerator, 28.5. And in the denominator, we're looking for, well, what's the actual wingspan on the model airplane? So we're going to set up the numbers as a proportion, where one ratio, 5 over 2, is equal to another ratio, 28.5 over x. So cross multiply, the cross products, we've got 5 times x is equal to 2 times 28.5. And so if we look, well, 5 times x just gives us 5x. And 28.5 times 2 gives us 57. So let's look at our calculator. 28.5 times 2, there's your 57. And solving for x, both sides need to be divided by 5. So 5x gets divided by 5. 57 gets divided by 5. So 5x, this 5 divided to that 5, 1 over 1. So we're left with 1x. And 57 divided by 5. Well, because we were given decimals, we can do the 57 divided by 5, and 11.4 is exactly what it's equal to. So the answer is not x equals 11.4. We can say the actual wingspan, that would be the answer. So the wingspan would be 11.4, and remember this is in meters. 11.4 meters would be the actual answer to the problem itself, not just x equals 11.4. All right, so this example will help you with problem number 8 and 31 on the lesson at the back of the book. And that will do it for lesson 2.6, ratios and proportions.